Hi everyone. So we covered a lot of stuff in the 2.5 task and even in the 2.5 Ready Set Go. I know you've already watched a video on the 2.5 Ready Set Go, but I want to just kind of pull it all together and make sure that we are all on the same page so that we can be ready for our assessment on Friday and Monday. So in order to write an equation of a line, all we need is two pieces of information. The first piece of information we need a starting point. Now we're going to talk about the two different forms that we have to write an equation. We have slope-intercept form and we have point-slope form. So we use slope-intercept form when the starting point has an x value of 0. That's when we're actually going to write the equation in slope-intercept form. So if you remember, slope-intercept form is f of x equals mx plus b. Alright, we use the symbol b, which stands for the y-intercept. So you'll remember what I've told you guys is every time you see a b value, I want you to make a little table and you put 0 for x and we put whatever the b value is for the y. That's why we use slope-intercept form though, because the table would start at 0. Alright, then we also have point-slope form. So point-slope form, remember, is f of x equals m times x minus x1 plus y1. It looks really scary, but we know that it's not. It's the same thing we've been doing. So we use point-slope form when the starting point has an x value that is not 0. So any other number that the table starts at, we're going to use point-slope form instead. Okay? The second thing that we need to write our equation is the slope. We need to remember that slope is just a pattern, or the rate of change. We use the symbol m for slope, and we know that m is equal to the rise over the run if we're given a graph. We can just count how much do we go up or down and how much do we go left or right. We can also say that slope is the change in y over the change in x, and we use that when we're given a table. But those are the two things we need. We need a starting point and we need a slope, which are the same things that we needed when we wrote equations before. So let's write the equation of the following. We're given our slope and in this case we're given a b value as our start. So we know if we were to make our table, we would start at 0 and our y value would be 8. That means then the one that we're going to use is slope-intercept form. So we know we need f of x equals mx plus b. So in order to write this equation then, it's just going to be f of x equals our slope, which is negative 2 over 7, times x, plus our b value, which is plus 8. So if we want to write it all in one color, we can just do f of x equals negative 2 over 7x plus 8. And there's our equation in slope-intercept form. Nice and easy. Alright, so then we want to write the equation of a line going through the point negative 2, 4. So here's where we're going to start. That's our starting point. So if we make a table, it's at negative 2, 4. And we're given a slope of negative 1/2. That's our pattern. So since this starting value is At -2, we cannot use slope-intercept form. It means that we have to use point-slope form. So we're going to use point-slope form because the x value is not equal to 0. So let's go ahead and write our equation then. We're going to do f of x equals, we know our starting y value comes first, so we're going to do 4, and then our pattern minus 1/2 times x plus 2. And this is x plus 2 because we know that we need the opposite of our starting x value. So if we want to truly write it in slope-intercept form, or point-slope form, excuse me, we're going to move that 4 to the back. So it's going to be f of x equals our pattern, so negative 1/2, x plus 2, and then that plus 4 is going to go at the back. They are the same thing. We just want to make sure we start getting in the habit of putting that starting y value at the end, just like we do with slope-intercept form. Okay, so now we're going to look at writing the equation of the line that goes through these 2 points. Well, we know if we're given 2 points, the first thing we have to do is make a table, because we don't have a slope right now. We can use either one of these as our starting point, but we don't have a slope. So we've got 3, 1, and -2, 5. And in order to find the slope, so I'm going to make a note actually, we need the slope. So in order to find slope, we're going to do the change in y over the change in x. So to go from 1 to 5, I'm going to add 4. That means my change in y is a positive 4. And my change in x, let's see, to go from 3 to -2, that means I'm going to subtract 5. So my change in x is -5. That means I have a slope of -4 over 5. And I can pick either one of these points as my starting value. So I'm going to go ahead and pick a starting value of 3, 1. That means in order to write this equation, because this is not an x value of 0, I'm going to need point-slope form. So f of x is going to equal, I start with my pattern, -4 over 5, and I need to figure out what goes in the parentheses with the x. Since I'm starting at 3, this is going to be a -3, and then I have a plus 1 on the outside because that's my starting y value. This is our equation in point-slope form. Now if we wanted to use our slope of -4 over 5, and we wanted to have a start value of -2,5 instead, we could do that. We would still have to use point-slope form. And now we're going to do f of x equals -4 over 5. This is going to be x plus 2 because our starting x value is -2. So we do the opposite inside the parentheses there. And then we're going to have the plus 5 at the end because that's our starting y value. Remember that your pattern should always go right next to the x, and the x needs to help us figure out what was that starting x value. And then the y value is going to go at the end. Okay? To write the equation from a graph, we're going to need to first make a table, because from here I can find some points, but I'm also going to need to find the slope. So let's see, I have a point right here. So that's the point 0, -2. And I have a point right here, which is the point 3, 1. Now we could either find the slope from the graph or we could find it from the table. I want to review how to find it using rise over run, but if you prefer to use the table, you are more than welcome to do that. So to go from this point to this one, I'm going to go up 1, which means I'm going to rise 1, and I'm going to run 3 to the right. So that's a positive 3. So that means my slope is 1 over 3. And in this case, I luck out that I can use the starting value of b equals -2, which is really the point 0, -2. So I could actually use slope-intercept form here. So if I'm going to use slope-intercept form, that's y of x equals my slope, which is 1/3, times x minus 2. That's my y equals mx plus b. Okay, moving right along. I know this is getting a little long. Pick out the important information and use the information to actually graph the function. So if we take a look at this equation here, we should be able to recognize that this is point-slope form, which means I must be given a starting point, and I must be given a slope. It's in the name. So let's see if we can find those pieces of information. Well, our starting point is shown right here. We're going to take the opposite of what's inside the parentheses. So it's a 1, and we're going to take whatever's outside, so it's a 4. That means our starting point is the point 1,4. The reason we take the opposite of what's inside the parentheses is if we think back to Module 1, we knew that we had to back it up to 0. So if my table starts at 1, I needed an x minus 1 in the parentheses. So it's always going to be the opposite. So I've got a starting point of 1,4. Our slope is always going to be what's multiplied in front of the x. So in this case, here's our slope. It's -2. Now we know if we have a slope of -2, that really means -2/1, which means I'm going to move down 2 and I'm going to move to the right 1. So if I jump down here where it says what key features from the equation help you graph the function, we know that we're going to have a starting point of 1,4 and we're going to have a slope of -2. Those are the two key things that help us graph this function. So let's go ahead and actually graph it. I'm going to start at the point 1,4, 2, 3, 4, there we go. And I'm going to use my slope of -2/1. So down 2 and over 1, down 2 and over 1. And I always like to go as far as I can with my slope. You just need to plot enough points to make it clear that you're graphing a line for us. But I always figure the more points I have, the better it is. So I always like to go as much as I can. And then we're going to need a ruler to actually draw our line through. And don't forget your arrows. There we go. Okay, the next one, we should be able to look at that and we should see that that is definitely slope-intercept form. That's definitely y equals mx plus b. So the two things that it's giving us are a slope and a y-intercept. So let's see here. Our slope is going to be the number in front of the x. So m is going to be 3/5. And we're given that y-intercept as our starting point. So since we're given b equals 1, we know that we can make our little table. We're going to start with an x value of 0 and a y value of 1. That means our starting point is the point 0, 1. So let's go ahead and do that, 0, 1. And we have a slope of 3/5, which means, since they're both positive, we're going to go up and to the right. So up 3 and right 5. 1, 2, 3, 4, 5. And then up 3 and right 5. Now I can also go the other way. I can go down and to the left. So down 1, 2, 3, and then left 5. And I can go ahead and do that once more. 1, 2, 3, 1, 2, 3, 4, 5. And we can go ahead and use our ruler to draw the line through. Okay, one more thing to talk about. Determine whether the following equations are equivalent. Show your work to support your answer. So remember, the word equivalent means are they the same? Can you actually show that they give us the same equation even if they have different starting points? So we have to remember that the way that we're going to do this is if we see parentheses, it means we need to distribute. And remember, distribute means multiply. So when we distribute a number, it helps us get rid of the parentheses. And then we are going to combine like terms. All right, so let's actually take a look at these then. We can see that this first equation here is in slope-intercept form, and there's nothing really for us to do. So for the second one, though, we see that this 5 is being multiplied in front of the parentheses. So we're going to take that 5 and distribute it inside. Distribute means to multiply. So we're going to have y equals 5x minus 5, and the plus 8 just tags along and comes with us. So when we distribute that 5 inside, it goes inside to both pieces, and we do 5 times x to get 5x, 5 times negative 1 to get negative 5. The next thing we're going to do is combine the like terms. These are both just ordinary numbers, so we're going to take them and put them together. We get y equals 5x, negative 5 plus 8 gives us a positive 3. So when we look at those two equations, they are not the same. They are different from each other. Which means, are they equivalent? The answer here would be no. When we distribute and combine like terms, we actually got different equations. So let's go ahead and do the same thing for number 2. Here's our original one that's already in slope-intercept form, so that one's nice. This one we're going to go ahead and distribute the 1/3 because that's what's being multiplied in front there. So we get y equals 1 over 3x, because 1 over 3 times x is 1/3 x. 1 over 3 times negative 3 is going to be negative 1, and the minus 5 is just going to come down. Now I'm going to go ahead and combine like terms. Since these are both just numbers, I can put them together. So I get y equals 1/3 x, and then negative 1 minus 5 is actually negative 6. So now I'm done simplifying this equation. So when I look at these two, they are the same, which means when I'm asked, are they equivalent, the answer is yes. All right, so that was a nice big review of everything that we did in 2.5. So hopefully that helps clarify some things. It's never bad to get extra practice. So if you followed along and took notes, that's great. If you had questions, or you should have followed along and taken notes, sorry about that. If you had questions and you wrote them down, that would be fantastic. Make sure you ask them and get some clarification before our test. Thanks for watching.